Hi everyone, welcome to this channel. So in the next few hours, I'll be demonstrating about how to develop a full stack DeFi applications and deploy to the Ethereum blockchain and interact with the front-end UI libraries and make it fully scalable. And for that purpose, I'll be using the latest tech stack and develop these applications where it is fully responsive and fully functional. And using For that purpose, I'm using the FigJam board to show the technical steps on how to actually build the full stack applications and deploy to the Ethereum blockchain. And I have categorized or divided into the backend and frontend. For the backend purpose, I have considered the smart contract development part, and for the frontend, that is process 2, that's the wallet creations and interactions by the users. The first step is I'll be starting with the backend about writing the smart contract, and I'll be using the Solidity programming language to write the smart contract for the crowdfunding smart contract. Then followed by the next step is the compilation of the smart contract using the hardware. The smart contract has to be compiled first, or the compilation of smart contract process takes place before the deployment, particularly in order to get the bytecode and API, because while the Solidity smart contract is written in Solidity programming language, which is actually human readable code, the Ethereum module machine actually doesn't understand it directly. So that is why we need the bytecode and API. Then after the smart contract has been compiled, so the next step is we need to deploy for the deployment purpose, using the hardware and some of the latest libraries, we can deploy to the any kind of blockchain. For me, I have selected the Ethereum. After the smart contract has been deployed, we will be getting a separate the smart contract address. And then what next step is we need to verify the smart contract. And after the smart contract has been verified and make it available across the network, then next step is we need to test it. We need to ensure that ensure that there are no mistakes or technical flaws, so that in order to avoid getting smart contract exploited. And now coming to the front-end UI libraries, so where I'll be using the Next.js. So the first step is connecting to the wallet. This will actually prompt the user to link their wallet, and for our purpose I'll be using the MetaMask. So this step is critical. I have considered step 1 because without a connected wallet, the user actually can't interact with the blockchain. So it is the entry point for reading the data, sending transactions, or even actually identifying who the user is. So what happens is, out here, when the actually wallet connections takes place, it actually provides the user account's address and chain ID to the front end, so which we will use the blockchain for blockchain interactions. Then after the wallet connection has takes place, then next is the importing and setting of smart contract, where we will be importing the API and smart contract address. So this step is actually crucial for setting up the connection between front-end and the smart contract that was deployed on the blockchain. And this step is required because the API or application binary interface define how the front end communicates with the smart contract, in which the functions of that Solidity programming language are being called. And the smart contract address, which we actually get after that was being deployed, actually simply to put, it tells the blockchain where the smart contract is actually located. So that's why out here we will be creating a contract instance using that API, contract address, and the wallet signer, so that this contract instance allows us to interact with the contract functions from the front end. Then that step 3 is now fetching the smart contract data. That means retrieving the information from the blockchain for our purpose, for this purpose of crowdfunding smart contract is like current funding progress, how much or the the how much funds has been raised. So the fetching of smart contract data comes before the sending of transactions, because the user need actually context before taking any kind of actions. So out here in my case, we need how much funding a campaign has received before actually deciding to contribute. And also this step 3 ensures that the UI is in sync with the blockchain's current state. And also these steps where actually we use the contract instance to call the read-only functions on the smart contract. So and also it brings or it fetches the data that we display to the user in real time. Then once the data is being fetched, then user can send the transactions. User can send the transactions out here, the contribution to the crowdfunding smart contract. And why this sending of transactions step 4 is actually taking place only after the fetching of smart contract, because fetching data step 3 fetching data ensures the user know the current state before actually making decisions. That is and also what happens is when the user actually triggers actions in the UI, like making contributions, and this send the transaction to the blockchain by their wallet. Then the next step is the step 5 is the displaying the updated data. So after the transaction is processed, so we need to update the UI. So this step 5 is required because the blockchain state changes or alter after every transactions. So we need to fetch the updated data to reflect these changes in the UI. And the step 6 is about the handling of smart contract events. So in the Web3 or in the smart contract, the events are actually, I would say, a signal emitted by the smart contract when something important happens, like contribution made or some kind of the goal has been achieved or target reached. So this step 6 handling of events is important because it allows us to listen for changes in real time and provide some kind of live updates without constantly actually refetching the data. And these are some of the steps for the front-end UI libraries, front-end part of the Web3 DeFi full stack applications. First is the writing of smart contract in Solidity programming language, getting it compiled, deployed, verified, and tested. Then also the front-end part about wallet creation, setting up contract instance, and the fetching of smart contract data, then sending of transactions, and the displaying all those data, updated data in the front end part. And the next is now, as I said earlier, for the programming language, I'll be using the Solidity, and for the smart contract part, and for the front end part, I'll be using TypeScript with the followed by Next.js framework, which is actually a React framework built on top of React, which has expanded its capabilities, and also had a server-side rendering. And I'll be using Next.js app router. And the UI part or libraries, I'll be using the ShadCN. ShadCN is provides a very easy to use, which is actually, of course, not a component library. We can easily copy paste and make it adjustable or make it aligned to the changes that we required for our purposes. And also for interacting with the Ethereum blockchain, so I'll be using the Ether.js. And as I said earlier, the smart contract deployment, testing, and purpose, so we will be using the Hardhat. And for the storing of data and for the user authentication purpose and interaction, so I'll be using the applet. Then the deployment, I mean for the purpose of testing smart contract, so I'll be using this applet testnet, which is not the main network, but this helps us to test whether the full stack smart contract actually really works or not. And also I'll be using the Alchemist API endpoint, Alchemist not API, the endpoint RPC URL for deploying and interacting with a smart contract. So the Alchemy actually provides a lot of features, so that is where I'll be using for the development of these full stack DeFi applications. So thank you for watching. In the next part, I'll be started coding the backend part and followed by the front end.